Greetings, my beloved scholars. I am Mr. Okafor PC, your online physics teacher. Today, our topic of discussion is the concept of acceleration. Acceleration. Recall in our previous class, we talked about speed, the concept of speed. And we said that speed is time dependent. The higher the speed, the shorter the time, the longer the time, the slower the speed. Today, we'll be talking to a closely related term to speed, and that's acceleration. Acceleration is one of the concepts that targets to explain motion in matters around us. Acceleration. Acceleration is closer to the idea of speed. The only difference is this. When speed is changing, it is tagged acceleration. When our speed increases gradually, it's called acceleration. Gradual increase in speed is called acceleration. When the speed is 0 meters per second and it counts 1 meter per second, 2 meters per second, 3, 4, 5, 6, 7, 8, 9, 10. You can notice that the speed is increasing. So the concept ceases to be speed. It becomes acceleration. In a nutshell, acceleration is increasing speed. Take for instance, when you enter the room and the fan is off, and you want to put on the fan because there is electric power, get into the regulator of the fan. When you switch on the fan begins to accelerate. It's not speeding. When your speed is changing and there's a kind of gradual increase, the best science term is acceleration. So the fan accelerates. Notice the fan blade. It begins to count 0, 1, 3, 4. You see the blades at the starting. All of a sudden, you can't see the blades anymore because the speed is doing what? Increasing. This increasing speed is the concept of acceleration. So you now know what I mean by acceleration has a kind of close meaning to speed. Speed gave rise to acceleration. Increasing speed is acceleration. Then it gets to a certain point, the fan maintains its speed. At that point, the fan enters a new concept called uniform speed. So when the fan maintains equal peaks, it's said to be at uniform speed. It's no more accelerating. So acceleration ceases when a body attains uniform velocity. And there is another term that is the same as acceleration, just that it is a gradual decrease. If acceleration is gradual increase, this term is gradual decrease. It counts like 8, 7, 6, 5, 4, 3, 2, 1, 0 meter per second. This gradual decrease in speed is called deceleration. Deceleration or retardation. So acceleration involves increase in speed, while deceleration involves decrease in speed. So I now want to believe that you understand that when speed is changing, either increasing or decreasing, it's no more called speed. It bears a new name, either acceleration or deceleration, except when the speed maintains uniform peaks. It's now called uniform speed or velocity. Okay, so the question becomes, how do we know that something is changing? Because acceleration comes with change in speed. The best way to know something is changing is time. When we talk about change, we're talking of time. This is why acceleration is not void of time in its formula. Acceleration must have time because it involves change. And what is changing there? Speed. So this is how we derive the equation for acceleration. Acceleration is change in speed or change in velocity. And when we talk about change, we're talking of what? Time. Time. The rate of change in speed. The rates that the change happens is acceleration. And that will take us to form of finding acceleration. So if acceleration monitors how speed changes, it involves time. And mathematically, we can say that A is equal to V over T. This simply means the rate of change in speed, and that's acceleration. Or the rate of change in velocity, and that's what? Acceleration. You can also see, as acceleration is increasing, the time is doing what? Reducing. But when acceleration decreases, the time does what? Increases. Inverse proportion. So acceleration is rate of change in speed or rate of change in velocity. A is equal to V over T. We have three kinds of acceleration. We have linear acceleration, we have angular acceleration, and we have acceleration due to gravity. At this stage in time, we'll be focusing on just these three types of acceleration. Linear acceleration. The word linear means line. This type of acceleration we see on a straight line. Linear. It happens on a straight line. Like a car accelerates. That's a good example of linear acceleration. Because the car moves on a horizontal plane. The train accelerates. Take note, a car does not speed up. A car accelerates. Every car begins from 0. It counts 1, 2, 3, 4, 5. That is acceleration. The fan accelerates. A car accelerates. Even humans accelerate. So acceleration is one of the most used terms in science or physics because every moving thing involves changing speed. Acceleration. So we have three types of acceleration at this level. Linear, the one that happens on a straight line. We have angular, the one that happens around a curve. Example, when you move around a circle, it's called angular acceleration. Angular, represented with the symbol alpha. Linear, represented with the symbol A, small letter A. Then the third one, we have acceleration due to gravity, represented with the symbol G. So I want to believe you now know the three types of acceleration: linear, on a straight line; angular, around the curve; acceleration due to gravity is the acceleration that is caused by gravitational force. Anytime a body falls downwards, we call the falling of the body acceleration due to gravity. We now will delve into acceleration due to gravity the more. So anytime a body is falling downwards in any planet, example the Earth, the falling of the body is acceleration due to gravity. Meaning that the body is falling because gravitational force of the planets, example Earth, is pulling it down. Acceleration due to gravity. And that also means that the speed is increasing. So any falling body has increasing speed. It's counting 1, 2, 3, 4, 5, 6. That means anybody that comes from a very far distance will fall with a very high speed because as the body is falling, in every second, the speed is increasing. Acceleration due to gravity. Okay, so let's go back to the various kinds of acceleration to explain in details. Okay, linear acceleration involves linear velocity over time. Linear acceleration will involve linear speed or velocity all over time. To get the units, it's very simple. Follow your formula once again. Ask yourself, what is the units? Units for finding speed or velocity. That is meter per second. This alone is the unit of speed or velocity. Follow the formula over. The next quantity there is time. What's the unit of time? Seconds over 1. Then let's now deduce the units of acceleration, linear acceleration. We'll be having meter over seconds times reciprocates. When you change division sign to multiplication sign, you reciprocate 1 over x. So I'll be having m times 1, m. S times x, x squared. Therefore, the fundamental units or the SI units for acceleration is meter per second squared or meter seconds raised power minus 2. Meter seconds raised power minus 2 is the same as meter per second squared. Let's prove that. X raised power minus 2 simply means 1 over x squared. Then every whole number has a denominator of what? 1. We can bounce back to m times 1 m over 1 times x squared meter per second squared. So the units of acceleration is meter per second square. Please do not confuse the unit of acceleration with that of speed. That of speed is simply meter per second, but that of acceleration is meter per second square. Why does it have square? Because speed already has time. Then acceleration is coming with a second time, which is also a denominator, and that's why the time there is squared. The unit of time there is squared. Seconds times seconds, giving us second square for acceleration, meter per second square. So let's go to angular acceleration. This type of acceleration we see when a car enters a roundabout. This type of acceleration we see in merry-go-round. The fun facility we call merry-go-round. This type of acceleration we see in the blades of a fan. Anything that is spinning or moving around a curve, it is no more linear. Therefore, its changing speed, its increasing speed is now called angular acceleration. Because the body is no more going on a straight line. It now goes in different angles. The angle is changing. So it bears a new name, angular acceleration, provided the body is increasing speed. Angular acceleration. A good example is the blades of our fan, the spinning fan, our merry-go-round, our vehicles about a roundabout. All these are examples of angular acceleration, provided the speed is changing and increasing. So to get the formula for angular acceleration, it will be similar to what we have in linear acceleration. Ask yourself, what's this term? This term is linear speed. Therefore, angular acceleration will have angular speed or angular velocity all over time. In the world of angles, time is the same. In the world of linear, in the linear world, time is the same. There is nothing like linear time and angular time. Time is the same, whether the body goes on a straight line or goes around the curve. That's why we maintain our time the way it is. But we use the symbol V for linear speed and the symbol W for angular speed or angular velocity. That explains why angular acceleration will be angular speed over time. To deduce the units, similar to what we have here, unit of linear speed is meter per second. Unit of linear speed is meter per second. Therefore, units of angular speed will be radians, rad per seconds. Rad simply means radian or radians. That is the unit of measurement for angular distance. We measure linear distance in meter, but angular distance is measured in radians or rad. That's why we're going for rad per second, just for angular velocity. Unit of angular velocity is rad per second, divided by, because our division here, unit of time is seconds. Therefore, we'll be having rad per second times 1 over second. Finally, we'll be having rad per second square. Rad per second square. That's the SI unit of angular acceleration. SI unit of angular acceleration is radians per second square. Radians per second square. Okay. Let's now make a little emphasis on acceleration due to gravity. We use the symbol G for acceleration due to gravity. The symbol G. Instead of A, we use G because of the word gravity. So what do we mean by acceleration due to gravity? Yeah, the force causing the increasing speed of a falling body here is gravity. So anybody thrown up gets to a point that it stops, and the earth, the mother earth, exerts gravitational pull on the body as the body begins to do what? Fall downwards. So the falling of that body towards the earth is acceleration due to gravity. And every planet has acceleration due to gravity, because every planet has mass that pulls on another mass. And that's what we call gravity. A greater mass pulls on smaller masses and even greater masses. So every planet is pulling down any particle of mass within its space down to itself. So taking the Earth, for instance, the acceleration due to gravity of the Earth is a constant. Likewise, all other planets. Every planet has its own constant. And this constant is dependent on the mass of that planet or satellite. So the bigger the mass, the greater the G. It's believed that the Earth has a greater gravitational force than the Moon. Therefore, the acceleration due to gravity of the Earth is more than that of the Moon. What did I just say? I'm just trying to say that things fall faster in the Earth than they do in the Moon. Things take time to fall in the Moon. They go gradually before they get to the surface of the Moon. But things fall faster in the Earth compared to the Moon because the Earth has a greater mass, the Earth has a greater gravitational pull, gravitational force. The Earth also has a greater acceleration due to gravity, a greater falling effect. That is G, acceleration due to gravity. And it's a constant in every planet. Every planet has its own constant. That of the Mother Earth, X. G is equal to 9.8 meter per second square. Record the units. Approximately, G is 10 meters per second square. What's the simple idea behind that constant? It's a constant. And it's just a very simple idea. Let's break the units into parts to help you understand the meaning of the constants. Taking the units into parts, what we have there is meter per second in 1 second. Speed in 1 second. It simply means that anything falling inside the Earth, in every 1 second, it falls with a speed of 10 meters per second. Did you get the idea? Anything falling inside the Earth, in every 1 second, covers a speed of 10 meters per second. 1 second, 10 meters per second. 2 seconds, 20 meters per second. 3 seconds, 30 meters per second. Did you get the logic? In every 1 second of a falling body inside the Earth, that thing attains speed of 10 meters per second. Just imagine when that thing has 10 seconds, then how much speed has been accumulated? Because the speed is increasing, and that's the idea of acceleration. This time due to gravity. 1 second, 10 meters per second. 2 seconds, 20 meters per second. 3 seconds, 30 meters per second. 4 seconds, 40 meters per second. 10 seconds, 100 meters per second. 20 seconds, 200 meters per second. Imagine when the body takes hours to fall. Then imagine the last speed the body will have before hitting the earth. And this is why anytime airplane land crashes, it explodes. Because the height, it takes minutes. It takes a lot of time for the plane to come from the peak it takes to the ground. And that type of height will cause a greater time. It accumulates excess time. And this excess time accumulates excess speed that when it land crashes, it explodes. Because the falling body has its speed increasing. This explains why somebody can attempt to jump from 1-story building and survive. But when you try that rubbish in 5-story building or skyscraper, your soul leaves the body. Because as you're falling down, the speed is doing what? Increasing. That's why we call it acceleration. Acceleration. Acceleration due to gravity. Gravity is causing a body to increase its speed. Due to gravity, a body falling has increasing speed. That's the idea there. 10 meters per second square. So we have to be careful with the Mother Earth when it comes to falling. Because in every 1 second, we gather what speed? We gather speed of 10 meters per second. Then imagine when you take 1 hour, 3,600 seconds. Just imagine the speed you have. Huge amount of speed. Yeah. That will get your bones into parts, shattered bones. So anytime a body is falling, the speed of the body is doing what? Increasing. Acceleration due to gravity. So I believe at this point, we now understand the concept of acceleration, which has to do with the speed increasing. Increasing. There must be an increasing order in the speed. But when the increase ends, it is no more acceleration. It goes back to uniform speed, where the speed has been maintained, uniform speed. Then when the speed begins to go down again, begin to decay, 876, it enters a new concept again. Deceleration, opposite of acceleration. Deceleration or retardation. When this acceleration happens on a straight line, linear acceleration. When it happens around the curve, angular acceleration. If linear acceleration will go with linear distance and time, distance over time, angular acceleration will go with angular distance and time, angular velocity over time is angular acceleration. Angular acceleration is angular velocity over time, radians per second square. Then when this acceleration is caused by gravity, it is tagged acceleration due to gravity. And acceleration due to gravity is constant in all planets. And that of the Earth is 10 meters per second square. Meaning that anytime a body is falling inside the Earth, in every 1 second, the body covers speed of 10 meters per second. 2 seconds, 20 meters per second, and so on and so forth. I believe you are very much at home with the concept of acceleration, and I pledge to keep physics interesting as we go on the course of understanding physics to a greater extent that you can do when your external exams and you can do when applications of physics ideas. Thank you and stay tuned on this platform.